Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will focus on AC and rectification from Cambridge A2 Physics. In this video, our main focus will be on bridge rectifier circuit, a very important topic from this chapter. Here we have a bridge rectifier circuit. As you can see, there are four ideal diodes A, B, C, and D, and they are connected in diamond shape. And this kind of setup we call is a bridge rectifier circuit, and a resistor is also connected, and the resistance of resistor is given. That resistance is equal to 2.4 kilo ohms. We will need this resistance later. What we need to answer, we need to just mark the letter P for the positive terminal of the load on figure 11.1. Positive terminal. Positive terminal of the load simply means that current entering side is a simple way to understand this one. Current entering side is positive terminal. Current entering side. Now we need to find out from which side current will enter. It will enter from top to bottom or bottom to top. This is what we need to find with the help of this power supply. So when this side is positive, means current flow from this power supply in this direction. At this junction, it has two options to go through A or B, but it will go through A because this is connected in forward bias. Again, at this junction, it has two options to pass through D or pass through this wire. It will go through this wire because this wire has no resistance. And this diode is connected in reverse biased. From here, we can see current will enter from bottom to top. So it means the bottom side has to be positive, or simply we will write here letter P. We have to mark P here. And then current will go this way. When it will reach at this point, it has two options. These two diodes are connected in forward bias, mean it can go through B or it can go through C. But it will only pass through C because B, this side is at higher potential as compared with this side. So that's the reason it will not go through B, because current always flow from higher potential to lower potential. So it will go to lower potential side in this direction and come back to power supply. So this is the case when this is positive terminal. We also need to understand the second case when the lower side is positive. Means when this side become positive, so current will flow this way. Current will enter and then current will go like this. At this point, it will pass through D and then current will flow like this. Again, it will enter from the bottom, and when it will reach at this point, it has two options to pass through C or B, but in this case it will pass through B because C other end is at higher potential. Because this is at higher potential, this is at lower potential, so it will go to this side. It will pass through B. Means current always flow from higher potential to lower potential, means for high value of V to low value of V. So this is very important concept. So this is how we can mark, and that's all for this part. For part B, potential difference against time graph is given to us. As you can see, time is on x-axis and potential difference is on y-axis. We simply need to calculate RMS value of current for the load. So how we can calculate, because in this case we don't have the peak value of current, only we have is the potential, and also we have value of resistance. So how we can answer this question? So first of all, we need to find RMS value of potential difference. Simply we can calculate like this, means we need to find VRMS, and VRMS simply we can find by V peak, means the peak value of voltage. We just need to divide by 2. So we can get VRMS, and when we have VRMS, then we can find out IRMS. That will be equal to VRMS divided by simply resistance. So this is the main concept, or we can say these are the main steps we need. remaining is just plug in values. So here you can see the solution I have written for you. So first of all, we have calculated VRMS because the V peak we can just read from here in this case is 6 volts. So we got VRMS. Now here we can find IRMS. Simply we need to divide VRMS by resistance, and the resistance is given to us. This resistance, as you can see, this is the value of resistance. We just simply divide it, and here is our final answer. For part B, simply we need to sketch on figure 1. For C1, we just need to draw the symbol for a capacitor to produce smoothing. For C2, the minimum potential difference across the load L with smoothing capacitor is 3 volts. And also again on figure 11.2, in this case this is figure 11.2, we need to sketch the variation with time t of the potential difference across the load L. So it means we have to sketch 2 times. So to answer this question, the first thing what we need to understand is that minimum potential difference is given to us. Minimum potential difference is given across the load. So it means the minimum potential, first thing we can say that V minimum across the load is 3.0 volts. So this is one thing. The second thing we need to understand, as it is a bridge rectifier circuit, this is bridge rectifier circuit, so output is a full wave rectification. Bridge rectifier, so the output is full wave rectification, means only we will get positive value of current. Full wave rectification. So this is very important point. Often students, they get confused what to do with this one, because this question is all about bridge rectifier. So bridge rectifier, full wave rectification. So based on these points, we can answer this question. So this is how I have drawn circuit for you. Actually, this is C2. This is not C1. If you can look at this one now, you can see, first of all, this was given to us without rectification. Then when we rectify this one, this is what we will get. After rectification, this is what we will get. So this is full wave rectification. So this is what we're gonna get after rectification. So this is after rectification. So this is what we will get after rectification. So simply we need to understand the negative become positive, so current only flows in one direction. The second curve you can see here, I have drawn here. So this is due to capacitor. So you can see at this point, this is the minimum potential difference, and this is 3.0 volts. And the same is true for this one. So we have to be clear about this. It has to be 3.0, otherwise you will lose marks. Again, you can see here current will decrease here. So a potential difference actually a decrease, and this is 3.0. Again, at this point you can see the potential difference here is 3.0. So this is how we need to draw this one. I hope it is clear to you. Let me show you C1 as well. For C1, simply this is what we need to draw, the symbol for a capacitor. Symbol for a capacitor. So here is our symbol. So this is what you need to draw, and this is our answer for C1.